So the problem is, suppose I have a stack, and in the stack you have been told that you can only use these operations: push, pop, peek is empty. Okay, the standard method that we defined in the stack, you're only allowed to use these methods. Okay, and suppose the stack has the elements like this: 1, 7, 3, 4, and 5. What you have been told is that sort this stack using above. Right? So basically, this has to be converted into 1, 3, 4, 5, and 7. This is my input, and this is my output. Okay. Just for your reference, for a hint, so you can think around the lines of recursion, and you can think around the lines of the stack properties. Are you guys clear? What is the meaning of this question?
Yes, sir.
Cool. So, any ideas, guys?
So, sir, I'm thinking like I will use 3 stacks, right?
So stack 1 we have been given. Initially stack 1 is, suppose this is like this: 3, 7, and 5.
And
This
the temp stack 2 is like empty.
temp stack is now empty.
Stack 3 is also empty.
Okay.
So, firstly, what I will do, I will just pick the top value of stack 1.
Okay. So
and,
the 5 the top value. Okay.
and put into like temp variable.
Into the temp variable. Okay. So
Yeah.
so you have
Then I remove it 5. Now I am continuously checking like by popping the next element from the S1, and if the value is greater than, then I will put that element into S2.
Okay. So the I pop.
My name is like I just want a smaller value from the S1, right? So in this case, I will get 1 in the temp value.
Okay. Okay. So what you said, that first I pop the value from the stack S1, and if it is greater than 5, then I put into the S2. This is what you said. So
7.
7 is greater than the 5, so I put 7 here, right?
Now 1 will come, but 1 is less than 5. So instead of 1, I will just put the value of 5 into the stack, and temp will be 1.
Okay, I put 5 here, and now
1.
is 1 now. Move 4.
Yeah.
So 4 is greater than 1. So I put 4 here again.
Yeah.
I put 3. 3 is also greater than 1. And now what happened to 1?
So finally, my temp value is 1. Now what I will do, I will just put the value of temp into the S3. S3, sir, not the here.
Okay, you put 1 here.
Yeah. So now I get the minimum value in S3. Now my temp will be 3.
Okay. Okay. So what now I can see is that, okay, so now your temp is
3.
3. Okay.
Yeah. Now I will check with 4, like compare with 4.
Now
Now
the
4 is greater than. Now I will put 4 into S1.
4 will come here. And then what you will do? So 4 has been taken out. Now you take out 5. 5 is also greater than 3.
Yeah.
5 here.
Then 7.
So
When the S2 is empty, then I will put the value of temp into S3 again. Then 3 will come here. 1 3.
So 1 3.
Then I will do same operation till last. Ultimately, I will get the sorted order in S3, right?
Yes, but you are adding 2 additional stacks, so the space complexity is order of n, and it is more than order of n, basically twice n, but it's still linear, but space complexity is linear. And second, the things that you are saying, how much will be the time complexity of that case?
N square.
Right, O of n square it should be, right?
Yes, sir.
The time complexity is O of n square. Anybody else who can improve this complexity? So suppose my initial stack that has been given is like this, say 3, 4, 1, and 7, 6, something like that. What I can do is that let's try to use recursion. So in the recursion, I again repeat, in a recursion you have how many things? First thing is that you have to do what the boundary condition is. Second, you have to focus on the logic, and the third, you have to focus on the recursive call. And when you are making a recursive call, the size should be increased or the decreased based on what the situation is. These are the three things. And the most important thing is the fourth point, which says that I should be knowing what is the meaning of this function. Okay. Now, let's try to say that, public void sort, and I'm given the stack. Yes. Okay. First of all, the termination condition. What should be the termination condition?
Yeah, is empty.
Yes. It should be either s is equal to null or s dot is empty. If this is either of the case, then in that case, I just return, I don't do anything else. Okay. And let's try to, pick the element here. Int number equals to s dot. And I call this recursively again. So, and I'll write something here. But before that, let's try to understand what is happening as of now. So if we do like this, and suppose if I have a smaller stack, let's take a smaller stack like this. If we do like this, right now what is happening is that the first time when I called, sort as like this, the first time the value of the stack was 3, 4, 1. And in this case, the number value was set as 1, right? And then again, the second call of the stack happened. S now remains 3 and 4. And the value of the number comes out as equal to 4. And then next time, the stack remains 3. And number remains as 2. Fourth time when it goes, then it is empty. There is nothing inside the stack. So it returns, right? When it returns, then from the fourth, it will go to the step 3, it will get to the step 2, and then we get to the step 1, and it will return. This is what is right now happening. Okay. So we have to write some logic here, logic here to reverse. Here for that, let me write a method, insert elements in order. Suppose this is a method, okay, and that takes a stack and that takes an element which is data, which is number. Now the function of this method insert element in order is that if it is a smaller element than all the existing elements in a stack, it should go at the bottom, right? And if it is larger, then it should go at the top, right? So this method, what it tries to do is that, so first of all, right, when it is returning, from here, fourth step to third step, now the number is 3, right? After this time, the stack was empty, so it will just simply go and put, in the stack, it will go and put 3, okay? Then when it went from the step 3 to the step 4, the number is 4, which is more than 3. So it just put 4 here. Okay. But when I go into the step 2, the step 1, it found 1 is here. So it will put 1 in the starting. Now how it does that magic, how does it put 1 at the starting and not here, is that how we have to implement this method, insert element in order. Okay, we have to implement this method so that it does that magic. Okay, so far so good. Are you guys with me? Is it clear whatever that I'm saying, or not? I'll repeat it.
Yeah, so please repeat once.
Okay, what I'll do is that in the next, I'll just give an array, suppose 3, 2, and 1. Okay, and suppose we divide into the 3 sections. So this is a dry run. This function 2. The first function that I have defined is void, and then suppose sort, okay? And this takes stack s. Okay, first condition is s is equals to null, or s is empty. In that case, return, don't do anything. Okay, this is clear. And after that, what I do, I get data int. Okay, and what I do is that I do sort, I do this, and then I call a function insert in order, and I pass s and I pass data. This is my first method. Okay, let me define all the methods and then we'll dry run and see. Okay, now this method is void. Okay, it takes s and it takes data. Okay, this method is if s is empty or s dot peak is less than equal to data. In that case, I simply do and put s dot push data. Okay. If that is not the case, what I do is that I again pop this and data is equal to s dot pop, and what I try to do is that insert data one. So this is data one. Insert in, I put s and I pass again the same data, and then I do s push data. Okay. So let's first try to understand this method try run. Okay. Let's try to first understand this. Suppose my stack right now is this. It's no different from this question. So for my stack right now is say 4 and suppose 1. Suppose my stack right now, initial case 1, then my stack is equal to empty. Okay. So in this case, when I call, insert in order and I pass s and I say pass 5. So what will happen when the call happens? It will hit this if, right? Because stat is empty. So it will end up doing s dot push 5 would have become 5, right? I'm just trying to write on this function too. Okay, I'm trying to write on this function too. Initially, suppose stack is empty and I want to insert 5 in order, then it went right. Now, suppose the case 2, let's try to take the case 2. In that case, now I'm trying to insert again, insert in order, say s and say 1 in this case. Okay. So what happens is that now the stack is not empty, it is already having the 5 element in it, right? So this if block will not get, so first time when it goes inside, right, the value of the stack is 5 and data is, so if condition doesn't get satisfied and data 1 value comes out to be 5, right, because this is what we are doing here in this state, data 1 equals to 5, and we again recursively call. So again recursively step 2 will get called, and when the second step call, the stat s will now is now empty, right, and data is still 1. So again it comes inside the if block and it hits the empty part. So what it does is that it enters that. So it enters 1 into that. So now the s becomes 1 and it returns, right? So when it returns, it comes back to the step 1. When it comes back to the step 1, the s is now holding data at this step. It comes back to this after this step. S right now is holding 1 data, and I am now pushing the data 1 here. I'm pushing on the data 1 here. So data 1 is 5 here. So this inserts 5 here. So basically this method, what it is trying to do is that it is trying to put the data at the right position. Basically smallest element at the bottom and the larger element at the top. This is how it is doing. Is it making sense?
Yes, sir.
Okay. So now what is happening is that if you see in this code, right, in this code, we haven't given a stack. Suppose the stack is 3, 2, 1. Okay. So this part is just a boundary condition check. So if I have to dry run this whole method, right? So function 1 को अगर अपन dry run करेंगे, ठीक है? So the first time when the method is getting called, that time the stack value was 3, 2, and 1. Okay. And inside that the data value that came was first 1. Okay. And then what happened, the second recursive call happened. At that time the value of the stack came out as 3 and 2, and the data value became equals to 2. And then third time when it went, it is s equals to 3, right, and data value came out as 3, right, and then the fourth time s got empty, and that what I have to do, I have to return back, right, I have to return back. So this is where the recursion comes back in the step 3. Now when it comes back to the step 3, at this moment what it does, it makes a call to this function insert in the order, right? So when it makes a call to this function, at that time the value of the stack is empty and it has to insert, what is do, it has to insert 3 into it, right? So when I call this function insert in order, what it will do, it will insert 3 into this simply because this the stack is already empty. So it will just our final stack that is in this the 3 has got entered. Okay. After that, again, I go back to the step 2. In the step 2, the value of data that has to be entered is 2. And the stack right now I have is 3. So I again call this method. Okay. So in this method now, the stack that I'm passing is having 3 already, and I have to add 2 in it, right? But what this method do, it does insert the element in the order, right? So what it will do, it will convert the array into like this. So it will do first 2 and then it will put 3. So now its stack is this. Now when I again go back to the first step, again now I have to insert 1, right? And at that time the stack is having 2 elements, 2 and the 3. It will again, from here I will call this function again, and now it will again insert 1 in the order. So it will now convert that into 1, 2 and the 3. So this is how the array will get sorted using recursion. So basically we are using recursion on the two different functions, and we are combining that into the one. So this is again a very classic example of a recursion which can be used to sort the stack.